Hello, I want to give you a little demo of what I built today with the GitHub Copilot CLI. It's this application called Coco Pilot. So Coco is the little monkey, and he is basically a copilot for a copilot, watching what Copilot is doing. So for example, let me give you a quick demo. If I say, first of all, let me go to YOLO mode. And if I say hi here, let's open up the event log and select the right session to connect to. It should come up. Not sure why the active session is not coming up here. I think it's this one where I said hi. Let's say basically, how are you today? Yeah, okay. So I have to apologize a little bit. I think the yellow status indicator is incorrect, but this application is watching the Copilot do stuff. And I want to explain how this works and how I coded this application. I had two motivations for this. First of all, I wanted to try the new experimental features in Copilot. So I saw that when I go to experimental, they are working on autopilot mode. So this enable autopilot mode for autonomous agent operation. Sounds interesting. And a fleet command, enable/fleet command that executes the implementation of large chunks of work in parallel. Also sounds very interesting. And something that I think wasn't here yesterday, but is here today is subagent compaction. Enable compaction instead of truncation for subagents. So this all sounds, I don't know. I don't fully understand it, but I wanted to understand it better. And this is one goal of this application, to visualize it and make it heard and sound and seen what's going on with Copilot. So maybe let's try a more realistic example here where I do Shift Tab to go to autopilot mode. And then I say /fleet. So I want to start a fleet of subagents, and I want to say make Coco the monkey larger and add many clouds. I can also speak here if I hit the mic button. Also, please add some nice background music. Okay, so I'm kind of giving it 3 tasks, and it should spawn a fleet of agents and orchestrate them to achieve these 3 tasks. So let's start this command. And you can see the fleet is deployed, and there are these events arriving here. One of them is exploring the code base. What is supposed to happen is that for every subagent that gets spawned, a little monkey jumps onto the island. I think it's working sometimes. The app is pretty buggy still. Okay, so while this is going, I think this will now basically go on for 5 or 10 minutes. Let me explain to you what's going on. There's this island theme. There's also an ocean theme, which is just a different skin. It has Flipper the dolphin instead of Coco the monkey, but otherwise it's almost the same thing. You can show the event log or hide it. You can turn sound on and off. I started the implementation of the app with a vanilla mode, just basically to have a dashboard and a status display of what's going on in the app before building out the 3D visuals and sounds. And there is a learn page. Maybe before we go to learn, there's also settings. You can say with which mode you want to start up and what the sound is like. Not super interesting. But let's go to the Learn page, because one goal for me was to learn how the Copilot CLI works and how these new modes work. So the typical agent loop is that you give a prompt and then the agent does stuff. It calls tools and at the end gives you a result. What the Copilot CLI does is it has all of these different events of different types, and it actually stores all of them in a .copilot session state file, where it just appends them as events.jsonl as JSON records. And this is the file I watch and what is driving this monitoring application. So I cannot basically control the agent, and I'm not hooking into the Copilot SDK for more fine granular things, what's going on. I'm just watching these event logs. How does this application work? Like I said, the Copilot CLI writes these event logs. I'm watching them with a file watcher. And then I also have a process monitor a little bit to see what's going on, storing everything in an application database. One thing that's interested, I developed a debugging API so that the agent can kind of see into the application while it's running and debug it and test it as an observability measure. So there's now a web service running here that is surfacing this kind of information. This is something the agent built for itself. Well, I told it to build it, and it did. The different events that exist is, and by the way, this is all basically things the agent figured out by observing the logs on my disk and by looking into the code base of the open source GitHub SDK and Copilot CLI a little bit. There's the session events, the user events, the assistant events, tool events, and sub-agent events. And you can see basically how these are structured and what their schema is. This is stuff the agent explored by itself and built the models for. There's also a session playback feature for testing. Actually, I haven't looked at this. And one funny thing that happened with the sounds is basically initially when we planned the project, I'll show you this later, but I told the agent to download 3D assets and sounds from the internet. And for some reason it didn't. Maybe it didn't manage, or probably it's not designed to download stuff from the internet, at least not in this type of quantity. And instead it decided to generate sounds by itself. It wrote Python code to generate these sounds. Let's first look at it. This is the ambient island sound, the ambient ocean, the monkey call, the dolphin call. So maybe let's quickly jump over into Visual Studio Code. Like I said, I told the agent to download the assets and it didn't, but it still has these sounds here. And what it did instead is it wrote Python code to generate waveforms and sounds. So from its memory of the internet, it kind of had a knowledge of what a dolphin sound is like, and it managed to write Python code which sounds almost like a dolphin. I think this is quite amazing. This came as a surprise for me. Monkey call. Oh, we had those already. Bubble. Chime. Typewriter. There was the idea that basically the monkey types on the typewriter when it's editing a file, the agent. Coconut crack. Error. Success. Goodbye. Yeah, that's it. And then it was supposed to basically take the event stream and the state of how many agents and sub-agents there are and combine this. And you can see already there's mixed results. Sometimes the agent manages to do stuff in the application. For example, it made the monkey bigger. It didn't put more clouds. Oh, there are more clouds up there, but they're not quite in the field of view. Okay, so this is the demo for the application. Let's look a little bit at how I worked. So how I worked was inspired by me seeing this video by Arnim, how he built a computer game from scratch with an agent. And there were two things which are interesting in there for me. One was that he had a progress.md file, which on every agent turn, he kept updating. And the second thing is that basically the agent cannot really work effectively on a visual application if he doesn't have an understanding of what's where. So in this case, Arnim made him write a log of all of the events, what's happening in the game. And when I started to work on this project, by the way, this is I think 20,000 lines of code and lots of docs documents. I didn't write a single character in there. All I did is basically I went to the Copilot CLI and I typed or spoke here into the prompt window to tell the agent what to do, or I did some manual testing and give feedback to steer the project. So to kick things off, I spent the first hour or two to work with the agent on a spec. So this is the files 1, 2, 3, 4, 5, 6 to try to spec out the project and the application and to say how things should work. I also told the agent to write Copilot instructions of how I want to work. For example, that it should not commit and push by itself, but I want to review things after it takes its turn and so on. Following these instructions, and there's this very important progress.md document. Following these instructions and working together with the agent worked, I would say, okay-ish, 50% of the time. And you can see that we had many turns going through many sessions here and several releases. All of this was written by the agent. So the idea was always that it would look at all of the documents and know what to build next. And then before doing that, I would review the application, tell it to fix stuff, and steer it kind of before continuing. There were two. All of it was done with Claude Opus 4.6, which is very cheap to use if you use it through the GitHub Copilot CLI, because it just counts premium requests and it doesn't count the tokens. So if you manage to give it bigger tasks that go for longer, for the same price, you can achieve more. So overall, I think this whole project cost me like 10 euros to buy, to build. There were two cases, like after doing the initial spec, I asked Google Gemini 3 to review it, and it gave some feedback. And I asked GPT 5.3 Codex to review it, and it gave some feedback. These were okay, but didn't add so much extra information. I think we could have gone without it. And at the end of the project, like at the end of the day, I asked Gemini again to review the project, and there were one or two things it pointed out that were broken or weren't updated. So that was kind of useful, but all of the rest was done basically just with Claude Opus from here. Yeah, so I mean, when working on these progress files, sometimes the agent loop didn't work perfectly in the instructions. So sometimes the agent kind of forgot to update this progress.md after taking its turn. And then I also wasn't sure what it changed. Sometimes it did commit things, sometimes it didn't commit things. Yeah, so this was a mixed bag, but overall, I think it was an okay collaboration to work with it. Also, it's very good at using the GitHub CLI. So if you have automated tests, then like the release pipeline and the CI pipeline, you can tell the agent, hey, there's an error here in the CI pipeline, go fix it or go run the tests locally. So this is something I think I haven't shown you yet, is if you want to run the tests locally, there's two types of tests. There's the unit tests. Not here. Okay. Okay, how does it work? npm run test unit or something like that. Yeah, this will run the unit tests. I almost never do this, the agent does it. And then there's end-to-end tests that use Playwright that will actually drive the application. So it should now launch and it will drive the application and then check that certain things are happening within the application. So through this and through this debugging API that I built in, I got some observability into the application. And I think this is one of the reasons why the whole experiment was kind of successful, of letting the agent write graphical and physical code about an island and stuff happening. That takes a while. I think this is it. This is all I wanted to show. So everything is on GitHub. You can see it here. All of the docs and the files. You can continue it by yourself. I even put in some of the logs I did. Where is it? Here with the. Did I put it in? Here, the terminal log. So, for example, here you can see the command I gave to the agent and then how it kept doing stuff. And then at some point, let's have a look. For example, here, I told it, yeah, start by committing what you have. And then I told it about bugs and gave screenshots and what to do. And then it came back and it did stuff for a while. And then I gave another command, giving it feedback again. So overall, it took like, I think 30 iterations and quite some work. So, but I didn't write a single line of code and I didn't write also these documents. Everything was managed by the agent. There's one more thing. The agent by itself decided to do a decision log on the first turn after the spec document. But then I think it forgot about this and we never talked about the decision log again. So this is very much outdated. So at the end, I think a lot of these documents are outdated and don't reflect the real application anymore. And I'm not sure basically for how long I could keep going in this repository and with this application before everything goes to waste and nothing works anymore and everything becomes buggy. So far, it's been working mostly okay. There are some performance bugs, and there's also there's some logical bugs in how the events are displayed. So, for example, now it says agent thinking, but the agent isn't thinking and it's not connected. So there are some state bugs when the certain pages open up or the app starts up for the first time that I haven't been able to resolve yet. So overall, it's still a buggy application. And even though I did a few loops, I wasn't able to get it into a bug-free state. I think probably also I went to the whole graphical and audio thing way too early, and I spent most of the time on this instead of just basically focusing on the event system and getting this in order. I think I should have spent an hour or two more on this and establishing more tests to get this into order first. And I mean, with these state bugs, I think it's also the problem that I'm not a React and web developer, and that's why I'm not very good at steering the agent or telling it where it made these bugs, right? Because I don't understand the code. Yeah, so this is all I wanted to show. Overall, I have to say I'm very happy with the experiment. Looking at it from very far above, I would say, bird's eye perspective, the agent steering worked, building an application worked. I built an Electron app for the first time. And also these parallel agents and fleet of agents, they did their work. So I'm very happy with this experiment.